Promises in JavaScript represent the eventual completion, or failure, of an asynchronous operation and its resulting value. They are a powerful way to handle asynchronous operations in a more manageable and readable manner. Here is an example of how to create a promise. We declare a constant variable named promise. We assign to it a new promise. The promise constructor takes a function as an argument, with two parameters, resolve and reject. Inside this function we have to perform the asynchronous operation. If the operation is successful, we will call the resolve function, passing the value as argument. Otherwise, we will call the reject function passing the error as argument. A promise in JavaScript can be in one of three states. The first state is pending. This is the initial state when a promise is created, and the operation is still in progress. The second state is fulfilled. This means the operation completed successfully, and a value is now available. The third state is rejected. This means that the operation failed, and an error is available. Here's an example of how a promise transitions between these states. Initially, the promise is in a pending state. We have a setTimeout function. Inside it, we generate a random number. If the number is greater than 0.5, the promise is fulfilled with the value success. Otherwise, the promise is rejected with the value failed. Promise chaining allows you to execute a sequence of asynchronous operations one after the other. This is achieved by using the .then method. Each then block processes the result from the previous promise. The result of each then block can also be a promise, which allows for chaining. Let's consider an example of fetching user data, processing it, then filtering the posts. First, we fetch user data, then process user data to get all the posts. Then we filter the posts to get the popular posts. Each then block can be used to process the result of the previous promise. Errors in promises propagate down the chain until they encounter a .catch handler. This allows centralized error handling for multiple operations. Any error in the promise chain will skip all subsequent, then blocks and jump to the nearest .catch handler. Consider the example of fetching user data, processing it, then saving it to a database. If there is an error like user is inactive, an error will be thrown and the chain will jump to the catch block. All the errors will be handled in the catch block. Promise.all allows you to execute multiple promises in parallel. It takes an array of promises as an argument. It returns a new promise that resolves when all of the input promises have resolved. If any of the input promises reject, the resulting promise will also be rejected. Let us consider an example of fetching user, posts and user stats. These three can be done in parallel. Promise.all will wait for all of them to finish. Then, in the then block, we will get user, posts and stats as an array. So, this is a very useful method to perform multiple operations in parallel. Promise.race returns a promise that settles as soon as one of the promises in the iterable settles, which means resolves or rejects. Consider a scenario where you want to fetch data from two different API endpoints, but want the data from whichever endpoint responds first. You can use Promise.race to achieve this. On the other hand, Promise.any returns a promise that fulfills when one of the promises fulfills. It only rejects if all promises reject. Consider a scenario where you are trying to fetch data from multiple servers, and it is fine as long as one of them succeeds. In such a case, we can use Promise.any to get the first successful result. Promise.all.settled waits for all promises to complete, regardless of their outcome, which means whether they resolve or reject. It returns detailed results for each promise, including the status and value or the reason for rejection. This is perfect for handling multiple independent operations. Promise.all.settled never rejects, and it always resolves with complete status information. Consider an example where we are trying to fetch users, posts, and comments from three different API endpoints. We can use Promise.all.settled to wait for them to finish and then check the result for each of them. The status will be either fulfilled or rejected, based on the outcome of the promise. Async and await are keywords in JavaScript that make working with promises easier and more readable. Async is used to declare a function as asynchronous. Inside an async function, you can use the await keyword to pause the execution of the function until a promise resolves. This makes asynchronous code look more like synchronous code. Let's compare promise chaining and async await. In promise chaining, we use the then block to handle the resolve value of a promise and catch block to handle error. In async await, we declare an async function, use the await keyword to wait for the promise to resolve, and try catch block to handle the error. Here are some best practices to follow when working with promises. Always return promises from then handlers to ensure proper chaining. Use catch for centralized error handling. Avoid nesting promises, and instead flatten the chains for better readability. Consider using Promise.all for concurrent operations. Add timeouts to prevent hanging promises. Here is an example of a timeout wrapper. We create a function called withTimeout which takes a promise and time in milliseconds as an argument. Inside it we are creating a timeout promise that rejects after the given number of milliseconds. Then we return a promise race between the actual promise and timeout. So, if the actual promise does not finish in time, then the timeout will reject. Let us explore some advanced promise patterns. One of the pattern is retry pattern. We create an async function retry operation that takes an operation which is also an async function, and number of retries as an argument. It tries to perform the operation. If it fails, it waits for some time and then retries the operation until the maximum retries are reached. Another pattern is sequential map. We create an async function sequential map that takes an array and a callback function as an argument. Inside the for loop, it calls the callback function with each element of the array and saves the result. After processing each element in the array, the function returns the array of results. This is useful when you want to perform asynchronous operations on each item of the array in sequence. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.